Hey guys, so this is the second video on joint continuous random variables, and in this video I'm going to discuss a new question. So let's just start with the question now. So the question is, suppose that two-dimensional continuous random variables, suppose that two-dimensional random variable x comma y has a joint PDF given by f x comma y, which is equal to 6x square y, where x lies from 0 to 1 and y lies from 0 to 1. So both x and y lie from 0 to 1, right? This is 6x square y and 0 otherwise, right? 0 otherwise. So the first part says that verify that this joint PDF so the area, this basically says that prove that the area under the curve is equal to 1. What is the area under the curve? The probability, the total probability, right? So when I integrate the joint PDF from 0 to 1, it will be equal to 1. So we need to verify this, that it is a valid PDF, right? So our PDF was fx comma y was 6x square y, right? And now I need to integrate this from 0 to 1, 6x square y dx dy. I am writing dx first. This means that this integral is of x, and dy is written after dx, therefore this integral is of y, right? So this should be equal to 1, right? So I am just taking 6 out because it's a constant term, right? And in this integral, this inside integral, I will treat x as a constant, right? Because this y as a constant, right? Because dy is written after dx. So let me just show you guys. I'll just draw a bracket. This is 0 to 1 x square y dx dy, right? So I need to treat y as a constant here, right? Because we need to find the integral of dx first, right? Or let me just write this, change this a bit. This is x square y dx dy, right? There is one more way through which I can represent this. I can also write this as, I can just take out y. I can just take out y. I can just take out y and write this as x square, right? Because y is a constant term too. And the reason why y is a constant term is we are dealing with dx here, right? So y is a constant term. I am just taking it out from this integral, right? Because this is the integral of x. So I'm just taking y out, and we are left with x square dx, right? And I'm putting a bracket here, and my dy will come here, right? Now if I try and find this out, I'll be getting y. Now the integral of x square will become x cubed by 3, and I'll draw a bracket from 0 to 1, the limits dy. This will give me 1 by 3. So 6 and 1 by 3 comes out, 6 into 1 by 3, from 0 to 1 y dy. This will become y square by 2. 6 by 3 into y square by 2, and my limits for y are 0 to 1, right? Ultimately I'll be getting 6 by 3 into 1 by 2, which is equal to 1, right? When I put in the limits, I'll be getting 1 by 2 here, right? So finally my area under the total curve area under the total area under the curve is equal to 6x square y is equal to 1. This implies that fx comma y 6x square y is when x lies between 0 and 1 and y lies between 0 and 1 is a valid PDF. Now the next part. Let me just explain once again what I did here, right? So this first integral, because I've written dx first, right? So this first integral belongs to x, right? Because I've written dx before dy. And the second integral belongs to dy because I've written dx after dy. Because the second integral belongs to y because I have written dy after dx, right? So what I did was, when I'm solving dx, when I'm solving this integral, I'll be treating y as a constant. And when something is a constant, we can take it out of the integral, right? So I just took out y, and 6 I had already taken out from both of the integrals, because 6 is a term which is a constant term for both dx and dy, right? But y is only a constant term when we are talking about dx. Y is not a constant term for dy, right? So I just took out y from this integral, and then I solved x. After solving x, I just took out the value of 1 by 3 from the y integral, right? Because 1 by 3 is a constant term, and then I solved y, and finally what I got was y, which proves that we have a valid PDF. Now if I solve the second part says that probability of x lying between 0 and 3 by 4 comma y lying between 1 by 3 and 2. We need to find this probability, right? So we are given the limits where my x lies between 0 to 3 by 4 and my y lies between 1 by 3 to 2, right? But there's a problem. My PDF is defined only when my x lies between 0 and 1 and my y lies between 0 and 1, right? Yeah. So 3 by 4 is less than 1, right? So we can integrate the PDF from 0 to 3 by 4, right? So we are already clear with x. When I talk about y lies between 0 and 1, right? And 2 is greater than 1. Therefore, this limit will transform into 1 by 3 to 1, right? Because I don't have any PDF for the value of y greater than 1, right? Let me show you the question again. So 6x square y, my PDF is 6x square y when my x lies between 0 and 1 and my y lies between 0 and 1. It is 0 otherwise, where otherwise means that if x is not lying between 0 and 1 or y is not lying between 0 and 1, the joint PDF will become 0, right? So if I take the limit from 1 by 3 to 2, I don't have a PDF for 1 to 2, right? So what I'll be doing is I'll be integrating it from 0 to 3 by 4 for x, which is clearly fine, and from 1 by 3 to 1 for y. So if I just find the probability, so probability, we need to find probability x lying between, let me just check if the question is right. Yeah, x lying between 3 by 4 and my y lying between 1 by 3 to 2, which is equal to probability of x lying between 0 to 3 by 4 comma y lying between 1 by 3 to 1, right? So let's just find this. X lies between, now I'm assigning dx to the second integral, right? So 0 to 3 by 4 and my y lies between 1 by 3 to 1, right? So this is 6x square y dy, because 1 by 3 to 1 is the limit of y, so dy comes first and dx. So I can just take out 6, 0 to 3 by 4, 1 by 3 to 1, and I'm left with x square y dy dx, right? Now this first integral is of y, right? So in this integral I can treat x square as a constant, so I'll be taking out x square, right? So if I just write this, I can represent this as 0 to 3 by 4, and if I just take out y, if I take out x square, I'll be left with 1 by 3 to 1 y dy, or let me just write this again. This is x square, this is x square, and let me just draw a bracket here. 0 to 1 by 3 to 1 by 3 to 1. This is 1 by 3, right? This is 1 by 3 to 1. This was y dy, and this is dx, right? So let me just move to the next slide. This will give me y square upon 2, right? This will give me y square upon 2. So I'm just solving it quickly now. So this gives me 0 to 3 by 4. You know, my handwriting is terrible. I need to write again and again. Let me just check if what I'm doing is correct. I'm so sorry. Yes. So what we're doing is 6 0 to 3 by 4. This is 3 by 4. Sorry. And this is x. This was x square, right? So x square. This was y square by 2, and this is from 1 by 3 to 1, right? So this becomes 6 0 to 3 by 4 x square into now 1 by 2 minus 1 by 2 minus 1 by 6, right? So this gives me 0 to 3 by 4 x square, 6 3 2 by 6, right? So 2 3s are 6, yeah. So 2 by 6, 1 by 3. So this gives me 1 by 3, and this gives me 6. 1 by 3 comes out. This becomes x cubed by 3 if I integrate, and this was dx, right? Dx. We shouldn't forget writing dx. This was dx, right? So this was dx. This was dx. This was again dx, right? So what we have here is from 0 to 3 by 4 is the limit, right? So this gives me 6 by 3, and this becomes the cube of and I'll just take out 1 by 3. So this gives me the cube of 3 by 4. So the cube of 3 is 27, and the cube of 4 is 64. So I'll be left with 3 and 3 goes away, 9 3s are 27. This gives me 18 upon 64, and I can simplify this, and this will give me 9 upon 32, right? So my probability of x lying between 0 and 3 by 4, comma y lying between 1 by 3 to 2, which is equal to probability of x lying between 0 and 3 by 4, comma y lying between 1 by 3, comma 1 by 3 to 1, and this is equal to 9 by 32. Let me just check. Yes. So this is 9 by 32. The answer is 3 by 8. I guess I've made some mistake. Let me just check. This and this goes away. We are left with 3. 2 9s are 18 and 2 32. 9 upon 32. Yes, this is 9 upon 32. I've made some error. I need to check. 1 by square. Oh, so this is wait. So this was not 1 by 6. This was square. So this was 9 to 18. This was 1 by 18. Right. Sorry. This was 1 by 18. Right. So 1 by 18. 1 by 2 minus 1 by 18. Right. So this was the square of 1 by 3. So this was 1 by 9. 1 by 9 to 1 by 9 to 1 by 2 was 1 by 18. So 1 by 2 minus 1 by 18. And this gives me wait. Let me just make some changes here. So what I'll be left with is 1 by 2. So I have 9 minus 1. 8 by 18. Right. 8 by 18. 8 by 18. 8 by 18 is so this was 8 and this was 18. 8 by 18. So 8 by 18 is 2 4s are 8, 2 9s. This is 4 by 9. So this is 4 by 9. Let me just erase this. 4 by 9, 6 by 3 into 1 by 3. So this was let me just write this again. Let me just make some changes. So this was 4 by 9. So I'm so sorry. So this was 4 by 9. This was 4 by 9, right? So this is 4 by 9. 4 by 9 into 6, right? 6 was out. So this gives me 4 by 9 into 6. And right, and this was the 1 by 3 comes out of this bracket, and I'm left with 27 by 64. 27, 4 and 64 goes away. I'm left with 16, and 9, 3, 27 goes away. I'm left with 6 upon 16. 6 upon 16. 24 upon 9. 6 upon 16. 6 upon 16. And 6 upon 16, which is equal to 2 3s are 6, 2 8s are 16, which is equal to 3 by 8, right? Yeah, so 3 by 8 was the correct answer. I'm so sorry for the mistake, sometimes what happens is when I'm making calculations, I'm trying to solve it quickly, so I tend to make these silly errors. So this was 3 by 8, right? So this was 3 by 8. Now our answer is matching. I made just a small error in my calculation. The whole method was right. I'll try to not make these silly mistakes. 3 by 8. So this was 3 by 8. Yes. So now we need to find the answer to the third part, right? So the third part says that the probability of find the probability of x plus y less than 1, right? So for finding the probability of x plus y less than 1, right? And we know our x lies between 0 and 1, and our y lies between 0 and 1. So what we can do is we can just let me just move on to the next page. Right. So what I'll be doing is I'll be just drawing a diagram, right? So this is y and this is x, right? So x plus y. So this is equal to x plus y equal to 1. This is x plus y equal to 1. So this is 1, and this is also 1. Yeah, so this is x plus y. This line is x plus y. This line is equal to x plus y equal to 1, right? So this whole region is x plus y greater than 1, right? And this whole region is x plus y less than 1, right? So now let me just erase all of this. So this line is x plus y equal to 1, right? And this is y equal to 1. This horizontal line is y equal to 1, and this vertical line is x equal to 1. Right. This line is equal to x plus y equal to 1, right? And we need to find the probability of x plus y less than 1. And we also know that our x lies between 0 and 1, so we cannot go here, right? And we also know that our y lies between 0 and 1, so we cannot go here, we cannot go below this origin point, right? Because our x is positive and is less than 1, greater than 0, and our y is greater than 0 and less than 1. So yeah, so we cannot move to the second quadrant, or we cannot move to the third quadrant, or we cannot move to the fourth quadrant. Why? Because in the fourth quadrant x is positive, y is negative, positive, negative. In the third quadrant both are negative, and in the second quadrant x is negative and y is positive, right? So we cannot move in these quadrants. Let me just erase all of this here. So we need to find this. We need to find the area of this triangle, and we'll get probability of x plus y less than 1. Yeah. So what we need to do is now we need to find the probability, right? So this shows this line is y is equal to 1, and this horizontal line is y is equal to 1. This line is x is equal to 1. This vertical line is x is equal to 1, right? Now we need to find the area, right? For finding the area, what I'll be doing is, now I can form the limits easily, right? So my limits can be, my x can lie from 0 to 1, my x lies between 0 to 1, my x lies from 0 to 1, right? And my y is lying between 0 and 1 minus x, 0 and 1 minus x, right? This is 6x square y dy dx, because the first integral is the limit of y and the second integral is the limit of x, right? So this gives me 6 comes outside, x 0 to 1, this is x square, this becomes y cube upon 3, y cube y square upon 2, y square upon 2, y square upon 2, and my limits of y are from 0 to 1 minus x, from 0 to 1 minus x, 0 to 1 minus x dx, right? Because dy is already utilized, so I'll be left with 6 into 6 from 0 to 1, x square 1 by 2, the square of 1 minus x, the square of 1 minus x minus 0 dx, right? I'll be left with 3 because 2 goes outside, and this gives me 0 to 1, x square into 1 minus x whole square, right? Yes, so now so now we just need to find the value of this integral, right? So what I can do is I can just substitute 1 minus x as t, so this gives me minus dx is equal to dt, my negative sign can go that side, and this gives me dx is equal to minus dt. Also if I just take t to the LHS, this gives me 1 minus t is equal to x, right? And now if I'm just making a substitution in definite integral, what I need to do is I need to change the limits also, right? So if when my x was going to 1, my 1 minus x goes to my 1 minus x, which is equal to t, goes to 0. Yes, and my x, when it is going to 0, my 1 minus x, which is equal to t, becomes 1. So my limits, this is a very interesting concept. So my limits, if I just substitute this 0 to 1, x square 1 minus x square 1 minus x whole square dx, 0 to 1, this becomes negative 3 0 negative 3 1 negative 3 1 to 0, and my 1 minus x was t, right? So this becomes 1 minus t, so 1 minus t whole square into t square, which is exactly the same, but yeah, an interesting concept came here, right? Oh, but my lower limit is greater than my upper limit, right? And I also have a negative sign, so what I can do is, this is a property, I can just multiply this with another negative sign, and my limits will shift. So what I'll be getting is, negative becomes positive, so I'll be getting 3 0. Now lower limit becomes 0, upper limit becomes 1. Yes, so this is the property of definite integrals, you can look that up, right? So this gives me 3 0 to 1 1 minus t square, which is exactly the same, but there was no need of making a substitution, but I just tried to make one. And while making the substitution, a very interesting concept came. I had a negative sign after substituting dx is equal to minus dt, I got a negative sign outside, but while substituting x is equal to 1 minus t, my lower limit became greater than my upper limit, and I also had a negative sign. So this is the property of definite integrals. This negative sign goes inside and changes the limits, and now I have my correct limits. My upper limit is greater than my lower limit. So this gives me t square plus t to the power 4 plus t to the power 4 minus 2t cube dt, right? and this gives me 3 into t cube by 3 plus t to the power 5 by 5 minus 2t to the power 4 by 4 from 0 to 1, which is essentially equal to 1 by 3 minus 1 by plus 1 by 5, 1 by 3 plus 1 by 5 minus 1 by 2. So this LCM of 3, 5 and 2 is 30. So this will give me 3 into 30, right? So 3, this becomes 10, this becomes 6 minus 15, so I'll be getting 3 by 30, which is equal to 1 by 10. Therefore my probability of x plus y less than 1 is equal to 1 by 10. Let me just check the answer. 1 by 10, yes, 1 by 10 is the answer. Now the answer to the fourth part. Probability x greater than y. Probability x greater than y, right? So x is greater than y. I need to draw the limits. So if my x is greater than y, my x becomes the limits for my x becomes y to 1, and my limits for y will become 0, will be a lower limit, and my upper limit will become yes. So or let me just write this in another way. This is not a correct way. I can do this, but I feel this is wrong. But I'll be doing this. I'll be writing this as, so my upper limit of y will become x, because y is always less than x, 0 to y, and x becomes 0 to 1, right? I felt this is very this becomes appropriate, so I wrote this like this. So y greater than x, and this gives me x goes from 0 to 1, y goes from 0 to x. This is 6x square y dy, because this integral signifies possesses the limits of y, and this external one possesses the limits of x. 6 comes outside, 0 to 1, x square comes outside, I'll be getting y square by 2, limits are 0 to x, d 0 to x dx. This gives me 6, 0 to 1 x square into x square by 2 dx, which is equal to 6 by 4, 0 to 1 x to the power 4 dx, which is equal to 6 by 4. I'll be moving on to the next page. Wait. This is 6 by 2, right? 6 by 2 x to the power 4 dx, which is equal to 6 by 2. Now integrating x to the power 4 gives me x to the power 5 from 0 to 1. This gives me 6 by 2 into 1 by 5, which is equal to 6 by 10, which is equal to 2 3, so 3 by 5. So my probability of x greater than y tha, x greater than y, yeah. So my probability of, where is my pen? So my probability of x greater than y is 3 by 5. Let me just check if you are right. Yeah, it's 3 by 5. They have also used the same method, right? Now we need to find the probability of the next part says that find the probability of, where is my pen, probability of x conditional x less than y conditional y less than 2, right? So what this says is this is equal to probability of this is equal to probability of x less than 1 intersection y less than 2 and this is equal to probability of y less than 2, right? Now what does probability of x less than 1 comma y less than 2 mean? Comma is, you know, intersection or comma, both of these are the same thing, right? So x less than 1, or I'm just writing the intersection y less than 2. Intersection is the same thing as comma. We are just, you know, referring to the joint PDF here. So probability of x less than 1 intersection y less than 2 means that we need to find the probability when x is less than 1 and at the same time y is less than 2. We are already given that y lies between 0 and 1, and we are already given that x lies between 0 and 1. Both of these things, both of our limits are signifying or are giving the value of this part of the numerator, right? So the probability of x less than 1 intersection y less than 2 is essentially equal to the probability of x lying between 0 and 1 intersection y lying between 0 and 1. Why? Because y cannot go above 1 and x is already less than 1, right? And we know that the value of this is equal to 1, right? This is what this means is we are just checking the total area under the curve, right? This is equal to the total area under the curve. We just found the value of this in the first part, right? You can check that out again. So this is equal to 1. This means that our numerator, which is probability of x less than 1 intersection y less than 2, is equal to probability of x lying between 0 and 1 intersection y lying between 0 and 1, which is equal to 1. So our numerator is equal to 1. Our numerator is equal to 1. Now let me just not draw. Our numerator is equal to 1. Yes, so our numerator is equal to 1. Now we need to find the probability of y less than 2. The probability of y less than 2. So let me just find the marginal PDF of y. For finding the marginal PDF, what I'll be doing is I'll be integrating this joint PDF over the limits of x, right? Over the limits of x. So my limits of x are 0 to 1 dx, right? For finding the marginal PDF of y, I'll be integrating this joint PDF over the limits of x, and for finding the marginal PDF of x, what I'll be doing is I integrate the joint PDF over the limits of y, right? So we don't need to find dy here, right? So this is only dx. So 6 comes out, y is also a constant, comes out, so x square becomes x cubed by 3, x cubed by 3, and my limits of x are 0 to 1, so this gives me 6 upon 3 into y, so this gives me 2y. So my f of y is 2y. F of y is 2y, right? Now my f of y is 2y. This is my PDF for y, where my y lies between 0 and 1. What I can do is I can just find probability of y less than 2. This is also equal to 1. I'm just, you know, showing you how to find marginal PDF. dy. So this becomes 2y square by 2. From limits are 0 to 1. So 2 and 2 goes away. 2 and 2 will go away, and we'll left with 1 square, y square from 0 to 1, which is equal to 1, right? Which is equal to 1, right? So my probability of y less than 2 is equal to 1. Therefore, my probability of x less than 1 conditional y less than 2 is equal to 1 upon 1, which is equal to 1. Let me just check if you are right. Yes. So thank you so much for watching this video. I hope you guys like it. It had some different concepts and we covered a lot of parts. I hope you got an idea of how to solve different kinds of questions, and I'll see you in the next video. Thank you so much. Bye bye.